I'm CK. Tonight we've got a filter from Feedback Modules out of Bucharest, Romania. And we've done some stuff with Feedback Modules before, liked it. And this is the 2600 emulation or reproduction. They're using the LM3900 chip for this, so it should sound pretty realistic to the, or pretty authentic to the original filter. So we'll put it together, put it in the rack, and see how it sounds. And I hope you enjoy the video. Feedback Modules, again out of Bucharest. I picked this up from thonk.co.uk, as I do many of my modules. Looks like a lot of little plastic bags, which is annoying, but what are you gonna do? Here's the front panel, and looks like 2 circuit boards. Let's look at the front panel first. Where's my pointy thing? We've got in and ATT, probably attenuation, frequency CV1, frequencies and CV2, so I think there's probably pots and jacks out, and then we have the general frequency and resonance for the filter. It's the main part of the filter. Seems reasonable. Here we see on this board, this is an okay board. It's not a great board, but it's okay. It's at least through-hole plated. And we've got jack, 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 pot, 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 and they're all 100K, so that makes it easier to not make mistakes. UCF 2600 or VCF 2600, CTRL control, revision 1, I believe. And then we've got some pin headers which will join the boards, and obviously some standoffs that go there too. On the back, Rev 1, looks like we've got 2 trimmers here for frequency, calibration, and bias. And we've got out offset and gain offset. It looks like we've got a couple of caps on the back here also to smooth the power a little bit. I don't see any diodes. Diodes may be on the other side. Yeah, here are the 2 diodes. So we've got a cap circle on both sides. I don't know which side they want the caps to go on, quite frankly. When we get the standoffs out, I'll see if there's enough space between the boards where the caps would go. And if not, I'll put them on the back. And the board itself, we've got the LM3900 and a little decoupling cap, 100 nano. And there's an LM458, that's a dual opamp. And transistor, bunch of resistors that all have their values listed on the board. A couple of more transistors, a couple of DNFs. Not sure what that is. It may mean just don't use it. And yeah, there's 1, 2, 3, 4 trimmers. And that's about it. Looks like a pretty straightforward build. Again, if you're emulating a synth from the 70s or early 80s, it's gonna be simple. Power cable, don't need that right now. And yeah, here's a whole bunch of little bags, which is unfortunate. But I'll put them in the recycling bin and hope. And here are the knobs, and the knobs are kind of nothing. There's no lock screw, there's no metal insert, they're just push-on plastics. They don't even look knurled inside. Here we have main PCB with all the bits and pieces, and here we have the headers and the ICs. So let me take a look. I'm gonna open this one up and get the standoffs out if I can find them. They may be in the mechanical bag here. Nope. Nope. Put all these in this bin. We've got, that looks like some 10 ohm resistors, just fusible links basically. Trimmers, and here the transistors are matched sets. So you'll want to put them, even though these are both 560Cs, all four of them are 560Cs, they're matched to each other, so you get the right responses. So you don't want to take them out of their bags and just say, oh, just put any 560C in there, because you don't want to do that. You want them matched. Sockets are the precision type, meaning they've got round holes. Again, I don't know why they call them precision. That's a little hubris in my opinion. And then we've got 3904 and a 3906 matched pair. Oh, the caps are really tiny. The caps are lower than the socket with an IC in it, so I'm not going to worry about putting them on the back side of the board. I mean, these foil caps are taller than the electrolytics. Decoupling caps, power protection diodes, little bitty resistors. So all look like quarter-watt resistors. Okay, that's all those pieces. And here are the pots, standard green pots. I'll put those in a different bin because they go on the front board. And I still am not... Oh, here are the spacers. Pin headers, power connector with keying. And the spacers are, yeah, they're tall enough that we can put those caps on the main side of the board. Now, interesting, the spacers are going to be held on with these nuts. Here's a sample. Let me zoom in on this. See if I can get this to focus right. Yeah, it's focused fine. One thing you may notice, these are lock washers with a fiber ring in there that provides the locking. That's somewhat overkill for eurorack, but it's certainly, you can shake your skiff around all you want and that's not going to back off. So it's nice, not necessarily needed, but it's nice. And the 3 chips. That says 558, 1458. That's not what the board says. Oh, there it is. Yeah, 1458. Yeah. So that's all the bits and pieces. And as you can see, it'll probably be a pretty quick build. And I'll get the soldering iron heated up. And we'll take a go at it. And I am going to see if there's a build guide. Obviously, with all the values listed on the board, we don't need it. But if they have it, maybe there's some guidance on how to trim it up when we're done with assembly and we want to get it all in tune with the right frequency response between CV values. We may want to do that. But for right now, get the soldering iron heated up and we'll start putting this thing together. There is no formal build guide for the product, but as I say, since everything is marked on the circuit board, you don't really need it. They have a Dropbox location that's got a bill of materials, two bill of materials, one in PDF, one in a spreadsheet file, part placement picture, and a schematic which is nice. I'll look at that. I haven't actually looked at that yet. We'll look at that. And then they have a page on calibration, which is the only thing I really was interested in. So it'll be easy for us to put all this together. And we're going to do as we typically do and on my channel, which is resistors first. And again, these are all 1/4 watt. It's not a very high powered module. And we do not, all we have on here are pots and jacks and pin headers, so we don't have to worry about searching for components on there. So let's see what we've got. We're going to start with these 12Ks. And there are 10 of them. Let's put one on to see how they fit and how far we have to bend the leads in. You have to bend the leads pretty close to the body. These holes are pretty close together. In fact, I didn't bend that one in far enough. Even on a 1/4 watt, it's still sticking out a little bit. So we've got one down, and we'll solder this one just to see how this board takes solder. All good. And it wicks through the through-hole plating very well, so we have fine connections all the way through. So that's all there really is to say about resistors. So I am going to put all the rest of them, there's a bunch left, and I will put them on and play back the video in fast motion and probably cut out a bunch of it because there's not much interesting in what I'm going to be doing for the next 20 minutes or so. So please enjoy resistor time. Oh, and where is my iPad? My iPad's right in front of me. And tonight I'll be starting listening to, on WQXR out of New York City on their iPad app, I'll be listening to the Septet in F major by Frederick Witt by the Consortium Classicum Manfred Honeck conducting. So enjoy resistor time. So that's resistor time for this kit, and I also added the two diodes because they're so similar. The only interesting thing was they gave us 9 100K resistors. However, I can only see 7 of them on the board, and then I went to the bill of materials. The bill of materials says 9, but then I looked at the schematic, and the schematic also only shows 7. So I got 2 more to put in spares. I think what I'll do now is I'll put the sockets on. Three of them. And getting the notches lined up with the notches on the circuit board. And we'll solder one pin, check it, yep, it's flat. Put the other ones on, and we'll speed through this. Wait a minute, oh, there we are. I was wondering where the other one was. Lost track. And we'll speed through this because sockets are pretty straightforward. And I'm going to pause the cameras for a second because I forgot to get the meat out for dinner tonight to defrost. Okay, dinner is defrosting, in case you were concerned. I'm going to put the power header on, and it's got a pretty clear indication of where the positive side is and where the red stripe negative side is. So we'll take our little power connector, and I think I'm going to want to go this way. Double check. Nope. We're going to go this way. That doesn't seem right. He's got an indent here. Oh no, I see. There are little shoulders on the connector. So by checking the keying on the connector and the keying on the socket, you can see that the red stripe is by the negative symbols on the board. So that will be A-OK. Let's see, now since we've got sockets on the board for ICs, we're going to have some decoupling caps. So here are our 100 nanofarads, which are typical decoupling caps for ICs. And when you see 100 nanofarad caps like this, you should immediately think, I need to put them near the sockets, because that's where they belong, to provide the power smoothing, for lack of a better word. Looks like there's a 10 nano in here too. Oh, the other 100 nano is inside this chip socket. I mean, it's fine. It doesn't go above the pin level, so it is not going to be a particular problem. Oh, here's the 10 nano. God, that's awful. Oh, that's no good. I mean, I'm struggling. It doesn't really fit well between the socket and this resistor. The socket is over the capacitor pad, which is not good. They need to spread that out a little bit. I got to solder that in place right now so it doesn't fall out on me. It won't cause any electrical problems, but it's just a little too close. Now we'll put the 4N7s on. And they're the same thing. They're too close to this. They barely fit. Okay. Well, I certainly don't have to hold them in place, that's for sure. Except that one is not very close. Is those little fellas done? Put the two electrolytics on. Oops. Good positive symbol on the board so you know what your polarity is all about. Now I'm going to do the transistors, and again, they're all matched. Not all of them, I'm sorry, there's a couple of singletons. But we'll pull the matched ones out. And so first we've got the 906s. Where do they go? Two 906s there, and then there's a 904 here, which I don't see. Oh, here it is. Here's the 904. We'll do the 906s first. Oh crap, where did it go? I just had it. Oh, there it is. I'm going to put all of the matched ones on next to each other. There's all the matched transistors. Let's see what's next. Got some trimmers. They're all 100K. Actually, that's something else. They're all 100. Oh, one's 10K, one's 100K. I mean, two are 100K. Okay. So those are the 104s, which are 100K. This is the 103, which is 10K. And there's a good indication of where the adjusting screw should be, which is pretty clear since it's got to go where you can use it. And then there are a couple of DNFs do not fit on the board, so just ignore those. And on the back of the board, by the way, for these trimmers, it tells you what they do. And that's useful if you're looking at it when it's installed in the rack. You can figure it out. And this, the not fitted one, is for bias. And I guess they figured they don't need that. We could probably put something on there, put 100K on there, and adjust the bias, but we'll just leave it the way it is. Now we'll do the last things for this board, which will be installing the pin headers. And it looks like, based on the outline, that we'll put the male pin headers on this board and female on the other one. That, as you can maybe able to see there, that I didn't get that. It's not touching, it's not seated well, but I went ahead and soldered it anyway, because I'll just reheat that solder and push on it, and we're fine. Let's get the other one on there. Same thing, it's not quite deep enough, doesn't matter. there we go. And that concludes the assembly on this board. And what I'm going to do is take a look here, make sure I got everything soldered, make sure there's nothing shorted. Oh, what goes there? Oh, it's a DNF. Oh, and there's one lead sticking up, which we don't really want in case. Okay, we're ready to move on. Now we'll go to the panel board. I think I'm going to do the pin headers first, because then I can put the pots and other things on without having to fuss about putting the panel on, front panel on for fitment and then taking it back off to put the pin headers on. So I'll put the pin headers on first. Those are all out of alignment. Looks good. Actually, this one went down pretty well. Let me double check my fitment. Well, that one's not straight, is it? No, I got this one leaning quite a ways. How did I do that? I got this one leaning quite a ways off. And I got this one leaning quite a ways off. I'm going to go use my hot air gun and straighten these out. My water heater came on, so there's background noise, but all I'm going to be doing right now is I'm going to mount these spacers to the board, so again, when I fit everything together, I never have to come back and take the front panel back off. Now we'll set all the pots and jacks in place. Now we'll set the panel on. Get my little clamp it together, and do some soldering. Now we'll put panel nuts on. And now we'll put the ICs on. We've got two of the 1458s and one of the main point, the LM3900. Now let me figure out how to get the tape off of this. Make sure that the little dot on the chip is on the same end as the notch on the circuit board printing. And those are all in and good. Okay, now we're going to mate the boards for the final time. There we go, and now we'll put the nuts on, and they also got lock washers for crying out loud. I've seen fasteners on jet aircraft that I've worked on that have less security than this eurorack module. Really, seriously, one or the other. Lock washers or lock nuts. You don't need both. And now, our cheapo knobs. Make sure all the pots are counterclockwise, so we have some hope that we'll get the index lines lined up. Now the power connector. Again, double checking that the red stripe is on the minus side. And there we go. There's the front. There's the side. The back. The other side. Top and bottom. Now we'll get set up to calibrate this thing. Okay, I've got the scope up. And I've got the meter here on the ground. At ground level, that is. First thing we're going to do is plug it in. I've got a little frequency central power supply here that I use on the benchtop. And we're going to look without any input signal and with input knob at minimum do the following. Connect a voltmeter. And we're going to do the output offset until it's as close to 0 volts as possible. Okay, that's at 2 point whatever. Let's be our 2. Right here. Grab my this at 0. I'm going to leave it there. 0.09 is just fine with me. Next we'll be checking the gain offset. And as you can see, I've got my function generator generating a square root at 5 volts at 10 kHz. I'm going to jerk the camera around so it can go up to the scope, because the scope is the output of the unit, and we want to make sure that that's 5 volts peak to peak also. And it looks like we're a tad bit low. So let me find the gain offset. Gain offset is there. See if I can make some adjustments to get that. Getting my head in the shot. Just bringing it up a little bit, bringing it up very slowly. Actually, it's not changing at all. I'm getting 8.4 volts peak to peak, and this gain adjust, even though I'm twisting it quite a bit, it's staying at 8.4 volts. So there's a little attenuation there, but I don't appear to be able to get it out with this trimmer, which is interesting. So we'll just leave that the way it is. We'll take the scope offline because we won't need that for the next step. Okay, so now we're going to do our low frequency adjustment. As you can see right now, and here. With the frequency knob there, I'm getting a little low as I take it all the way out. There, I need to come further back on that because I want to get a little bit of low frequency at the minimum position. So we're going to adjust VR3. I'm going the wrong way. There we go. We're starting to get some low freak, and that's at minimum. I mean, you can adjust this to whatever you want your lowest frequency to be, I guess. Came up a little too high. Let me hold the mic closer to the speaker. So I think that's where I want the low frequency to be. Hear that? That's very low. And as we adjust the frequency, you can hear it start to resonate right there. It's self-resonating. Obviously, I don't have any input going in there. So I think that's calibrated enough for me. Now we'll put it in the rack and see how it sounds. Okay, we're in the rack. Let's turn it up a little bit, and I've got a sequence going from my various things to my even VCO. So let's open up frequency a little bit. Let me let you hear the dry signal first. So that's the dry signal. So that's a little bit filtered. Now open the frequency up more. And that sounds pretty much like the dry. Take resonance all the way off. Turn resonance up. Doesn't do anything with frequency all the way up, which is not surprising. Now take frequency down a little bit, change resonance. You can hear it doing a little squawking. It sounds kind of interesting. Change frequency. I'm going to put some CV from an LFO into frequency CV1. Let me slow that down a little bit. Speed it up a little bit. Speed it up a whole lot. Now we'll go into frequency CV2. I'm going to take one out for the minute. That sounds pretty neat. We can change that. Change the frequency again. Little resonance there. Change the CV2. put resonance 3, CV3 back in. Change the offset for that. Now I've put both of these to very low. You can hear it cycling up the ramp. Turn those up a little bit more, a little faster again. And you can play with them, obviously. I'm going to take those back out for the moment. Actually, let me put them to 12 o'clock. Let more of the frequency pass. Turn these up both very fast. So as you can see, adding these inputs makes it interesting. Take them back out. And so on and so forth. It sounds like a good filter, and being able to vary these with, say, an LFO makes it sound even more interesting. And as you saw, pretty straightforward kit, and sounds pretty neat, and I hope you enjoyed the video.